Welcome to ANAARM for training in solar photovoltaic system installation and maintenance. Today's topic is components of solar radiation. The instructional objectives are stated as follows. 1. List the two primary components of solar radiation. 2. Identify the portion of solar radiation that reaches the head directly without scattering. 3. Name the component of solar radiation that has minimal significance in solar PV systems. 4. Draw a well-labeled diagram of solar radiation indicating all three components. 5. Present in tabular form the relative importance of the radiation components in solar energy system. Now let's quickly look at what solar energy is. The sun produces an enormous amount of energy every second. Only a small fraction of this energy reaches the earth. The energy reaching us from the sun is known as solar energy. It is important to know that the solar energy, which is a fraction of the sun's radiation that reaches us, is more than enough to power all human needs. Components of solar radiation. The sun's radiation reaching the Earth's surface is commonly classified into two components, namely direct radiation and diffuse radiation. Now, direct radiation. This is the portion of solar radiation that travels in a straight line through the atmosphere and reaches the Earth's surface without being significantly scattered. For example, when sunlight strikes the ground and creates a sharp shadow of an object, that energy is direct radiation. Diffuse radiation refers to solar radiation that has been scattered by air molecules, water vapor, dust, and other atmospheric particles before reaching the Earth's surface. For example, even in the shadow of a building, we still receive light. This is diffuse radiation. Another component which is less significant in solar PV systems is the reflected radiation, also known as albedo. The fourth component is called global radiation. It represents the total solar radiation received at the Earth's surface, which is the sum of direct, diffuse, and reflected radiations. On a clear day at noon, direct radiation may account for 70 to 80% of the total. Diffuse radiation may contribute 20 to 25%, while reflected radiation is usually small, 2 to 5%, but it can be higher over snow or water surfaces. Together, these form the global radiation received by solar modules or panels, as we normal commonly as is commonly referred to. Equation 1.1 represents the mathematical representation of a global radiation, while figure 1.1 highlight the different types of different components of solar radiation. To your left, you see the sun, and to your right is the solar module or panel. The sun rays are represented by 1, 2, 3. Ray 1 is passing through the cloud before striking the solar module, while ray 2 is directly hitting the solar module. That is the one we refer to as direct or beam radiation. The reflected radiation hits the ground first before striking the solar module. Now, any component of solar radiation, direct, diffuse, or global, can be harnessed and converted into heat. For example, in solar thermal systems, for drying clothes, cooking, or heating water, or electricity, for example, in photovoltaic systems. However, direct radiation is more efficient for concentrating solar power, CSP, while both direct and diffuse radiation contribute to photovoltaic PV electricity generation. The relative importance of each component in these systems is summarized in Table 1.1. The components are listed to the left: direct radiation, diffuse radiation, and global radiation. So the various systems we are looking at are solar photovoltaics and solar thermal. So you could relate with each of the components and their relative importance in the two systems. For direct radiation, you have each under solar photovoltaics as efficiently converted to electricity, and it is also essential in concentrated solar power systems. But when it comes to diffuse radiation, it is not so efficient in CSP. In fact, it cannot be concentrated according to some authors. While in solar photovoltaics, it can still be converted to electricity by PV cells, allowing them to generate power even under cloudy or overcast conditions. In summary, photovoltaic systems can utilize both direct, as you saw in table 1.1, 1.1 rather, and diffuse radiation, while concentrated solar power systems require strong direct radiation for effective operation. Solar energy can be converted into one, heat for drying clothes, cooking, or heating water. Then two, electricity using photovoltaic cells and solar thermal plants. This brings us to the end of this topic. We hope you have learned so much and you will be able to answer the following questions. 1. Present in tabular form the relative importance of the radiation components in solar energy systems. 2. Draw a well-labeled diagram of solar radiation indicating all three components. 3. Name the component of solar radiation that has minimal significance in solar PV systems. 4. Identify the portion of solar radiation that reaches the Earth directly without scattering. And 5, finally, list the two primary components of solar radiation. Don't forget to subscribe to get more videos. Thank you for your time.